So
Even the layers, no information.
The layers are limited
no,
compared to neural networks.
no, no, the layers are not limited. You're getting there. So sorry. No. So the hint is in the name restricted, right? What is restricted in it is the structure. The question paper is leaked out, so your answer is not taken. So the restricted part there is the communication between the layers. Intra-layer communication is restricted in a Boltzmann network, right? So why is it restricted? Because what it did was a jackknife sampling, right? So you don't want one kind of a sample to interfere with another. So you restrict the communication between two layers, and that's exactly why it's called a restricted Boltzmann's machine. So I'll wrap up Boltzmann's machine with that, and let's go find a critical overview of existing techniques, because the reason it's important is that there are a lot of academic techniques that are used for recommender systems. And most of these systems, what they do is, as the name suggests, they're quite academic in nature. And they give very good performance, and they perform very well on ground truth data and golden data and whatnot. But you need to take into consideration a main factor. When you try to implement them in a real-time system, you have many constraints. Most important of them is the time constraint and the cost constraint. And where does the cost constraint come here? It's in terms of server space and the time itself, right? Time is cost. The more you delay your delivery, the more you lose, right? So these are some of the major constraints. Also, you have the server space limits and the time taken to run and whatnot. And you have a classic issue of the Netflix competition, which my colleague referred to earlier, where they offered a $1 million, but do you think they actually implemented the solution that won a $1 million? They actually did not. They did not implement the $1 million solution. They implemented a solution which came third or fourth, I guess. And the reason they did not implement the winning solution was that the winning solution was an ensemble of 108 models. And the performance increase it gave was very negligible for them in comparison to the cost savings they would get by implementing the model that came third or fourth. So for them, a $1 million was not much compared to the performance measures, right? That's where you come to so-called real-life examples or real-life techniques. And Abhi said we're not going to market, or we're not going to market Deloitte initially.
So time to be brutally honest, we will do that to a certain extent. But of course, I mean, the idea is for you to understand this is an example of what real-life recommender systems are like. What we've been telling you so far are exactly what the textbooks will tell you. What we've not told you so far is that if you go into real-life data and try applying these, you'll face a ton of hurdles, and beyond the point, you'll start to realize this isn't working as easily as I thought. So we're now getting into what we believe does work and work very well, and we're giving you examples of that. So Karthik, over.
Yeah, so we have something called as a matrix completion engine, which is a Deloitte proprietary algorithm. And it's a form of recommender system, which has been developed in Deloitte by this guy. He's a partner and director in Deloitte, and he's a statistician. So what does this matrix completion engine do? Let's not get into the code technicalities of it. Let's just assume that it works really well. Okay, it works really well on real-life data. So one of the, if you want to measure the comparison of performance before looking into what it actually does, this is the performance it gave on the Netflix data, 0.8907. It was enough to come on the top leaderboard, top 5 performances. It's 0.8907, and it's not an ensemble of any model. It's a single model by itself, right? And comparing it with other popular techniques, which are matrix factorization and Boltzmann's machine, it was way ahead of Boltzmann's machine and considerably ahead of SVDs, right? These were the two most popular techniques that were used in different forms on the Netflix competition. And the advantage of this model is that it can scale up in real time, right? You're not really increasing the server space, or you're not solving the problem technologically, you're solving it rather algorithmically. You're scaling up the mathematics instead of scaling up the technology. So that is one of the major advantages of this method, and it's platform agnostic. You can implement it on really any platform, and it's blazing fast. It's real time, right? If you want to get more information about this, you can catch any of the speakers here, or yeah, you can catch any of the speakers here, and we would be more than happy to provide details about this. So I'll give you 2 use cases where this particular algorithm was used. We cannot name the client, but we did something called as a revenue leakage problem, which is popular in most of the billing. Any industry which involves billing has revenue leakage, right? You might buy 100 products, and you might sell 100 products, and you might bill it only for 98 products. You might miss 2 products, right? This is an example of revenue leakage in a medical chain, diagnostic or a hospital chain, right? So you get tested for 10 conditions and you bill them only for 9 conditions. There might be a condition which you might have missed billing the person for. So that is basically a missing data problem. Something is missing from the matrix of that particular user. So you can use this, we use this algorithm to solve the problem, and it's a use case which can be extended to most of the recommender systems even. Like for example, you have someone buying your monthly groceries from an online portal, and one fine day you go like, okay, hey boss, you did not buy your oil for this month, and it recommends, did you forget to buy your oil supply for the month, right? It can be scaled up as a recommender system too. So another example is, another example was for a Tata Sky equivalent of a US based client, where the client wants to capture every information that the viewers provide from their set-top boxes in 15-minute intervals. But it so happens that not every 15-minute interval is populated. In every 15-minute interval, the person who is viewing or the customer needs to provide information about what he's exactly watching, so that this television chain, they can sell this data to advertisers for more effective advertising, right? Who is watching and what they're watching, when they're watching. So that was like a very sparse problem where you had extremely sparse matrices, right? And the same algorithm was used in it real time, right? So these are a couple of use cases that you use this matrix completion engine for, and we would be more than happy to answer questions about this, preferably offline, technical aspects of it or how to implement it. So yeah, I would conclude my talk with this, and let's get on to some questions. I think we have around 7 to 8 minutes left. Yeah. So.
Great. So the latest application, yes, we have a question there.
So guys, I wanted to know if there's any objective way to evaluate the efficacy of a recommendation engine.
Efficacy.
Yeah, efficacy as in saying, how it's recommending the right content to the right user.
So it's.
Good question. Thank you. Yeah.
So you do it the same way you do for any other model, right? You have your test data to test your performance on. So there are several measures. For example, the Netflix competition, it uses the measure called as RMSE, right? Root mean squared error. So if you're not aware of it, a very simple way to put it is, say a movie is recommended, a movie's actual rating is 5, and my recommendation system gives that movie's actual rating is 5, but it's actually missing. So I'm trying to.
Yeah,
Yeah, the square difference between it.
Hello.
So if my
Hello.
RMSE is 1, I can
Hello.
as well say that, okay, it's plus or minus 1 is the error in prediction. Something of that sort. Yeah. Any other questions? Yeah.
Examples from the education analytics industry? Any examples from the education analytics industry, if you can capture? I have been looking forward to such examples since morning, so I thought probably will ask any kind of education projects you have worked on, any kind of education analytics example.
Yeah. You mean to? Oh, you're asking us if we have worked on any education analytics. Okay.
In general, but in specific. Lots in general. Yeah, but in specific recommendation.
I don't know if you have an actual use case, but I can very easily think of potential. You
few courses and you have 10 different courses to choose from, students have the option of choosing 5 of them. The reality is, even before you actually roll out the course, you don't know how many you'll choose for which. There's a potential some will choose, 100 will choose for one of them, and maybe 5 will choose another. You need to plan accordingly with your revenue, with your strategy of who will come in and teach, etc. This is a very easy application to figure out who choose what, provided you know certain choices beforehand. Okay, so that's one easy I can think of instantaneously. But other applications in the educational this thing, let's take this. Yeah. Okay. Any other questions?
Yeah.
Yes, sir.
Amazon banner, why does it keep
Why
chasing
do
us
they keep
along?
chasing you? Because they want you to buy their products. Yes.
I don't hear you. Can you pass
There's
on
no
the mic?
sunset.
Behind the banner which says if this person has not clicked it 5 times I have showed, then I should stop showing it. Do they have rules like that?
My example of 2 years, that guy gave me.
Yeah. They're examples of bad recommender systems, right? So, yeah. So it also depends on a lot of factors. Companies like Amazon, I don't exactly know what algorithm they use in the background, but I would assume that they would track your IP and the clicks that go through your IP and all those things, right? So it need not necessarily be that you click it. So if anyone in that region, if they are if they have a propensity to click on these kind of ads, it would naturally advertise it to people in that IP. So by personal recommendation systems, yes, it is personal,